So this one might seem a little complicated. It's actually quite simple once we know some trig identities and we simplify that integral that is a parameter. So the first parameter, this integral here from -1 to 1 of sine of w, all we have to do is recognize that sine of w is odd, and using the properties of integrals, this integral is going to be equal to 0. Now I can go ahead and rewrite my integral like this. So we're going to go ahead and use substitution. Du is equal to 2 dx. I can divide the 2 to the other side. And we get that du over 2 is equal to dx. And now I'm going to change my parameters. So when x was equal to 0, that means that u is equal to 1. And when x is equal to pi over 2, that means that u is equal to pi plus 1. And so now I have this integral. 1 to pi plus 1 of sine squared u du over 2. Let's rewrite this. I'm going to put the 1/2 on the outside. And it looks like I need to make some space on the blackboard. In order for us to integrate this, we have to remember that sine squared u is equal to 1 minus cosine of 2u over 2. That's one of the row reduction identities. Now we have 1/2 integral from 1 to pi plus 1 of 1 minus cosine of 2u over 2 du. We can also bring that 2 that's on the bottom on the outside. And that's going to give us 1/4 integral of 1 pi plus 1 of 1 minus cosine of 2u du. And I still have that 1/4, but I'm going to go ahead and start applying the first fundamental theorem of calculus. So that first integral for 1 is u minus, this becomes sine of 2u over 2. If you pause the video and work that out on your own, I basically use another u substitution for the 2u, and that's how I got the 2 on the bottom. And so now I can go ahead and plug in my values. I have 1/4 on the outside, pi plus 1 minus sine of 2 pi plus 2 over 2 minus 1 plus sine of 2 over 2. Nothing quite interesting happens here except that the 1's cancel out. And now I can go ahead and distribute the 1/4 into everything, and that gives me pi over 4 minus sine of 2 pi plus 2 over 8 plus sine of 2 over 8.